So in this video we're going to look at organic chemistry, but we're specifically going to focus on benzene, and our learning intention is to discuss the bonding and characteristics in benzene and aromatic compounds. So this is the structure of benzene here that we have come to know during the study of our Leaving Cert course. And we've kind of briefly discussed already why we don't have this alternating double single bond setup in benzene, and instead we have this aromatic ring. But we're going to look at this now in greater detail in this video. So benzene has a molecular formula of C6H6, and it was established in 1834 after the compound's discovery by Faraday. The formula of C6H6, it caused mystery for many years after its discovery, as no explanation had been found that could account for all of the bonds. We know that carbon usually has 4 bonds and hydrogen usually has 1. It wasn't until 1856 when a chemist called Kekule deduced the ring structure of benzene, and the cyclic nature of benzene was confirmed by a crystallographer called Kathleen Lonsdale, and she's actually Irish. So to begin, benzene is a planar molecule, so we know that planar means the bond angles are 120 degrees and all atoms lie in the plane of a page. Each carbon atom has 4 electrons in its outer shell, and each carbon atom is bonded to its neighbour with 1 electron from each atom. Since each atom has 2 neighbours, this uses 2 of the 4 electrons from each carbon atom. So 2 have been used, so there is now 2 electrons left on each carbon. Now, we know that each carbon has a hydrogen coming off it, so another electron is used for the hydrogen bond. So that means we have only got 1 electron left then. That means in total in our benzene molecule that there is 6 electrons left, and that's 1 electron from each carbon. So the 6 electrons orbit the atomic nuclei at right angles to the plane of the ring and also overlap each other. So consequently there's a blurring of the orbitals both above and below the ring, and the blurring comes from 3 electrons in the upper ring moving around and 3 electrons in the lower ring moving around. And this is indicated by this small little diagram here. As you can see, we've got a blurry ring above and below the plane, and that the top one is coming from the 3 electrons and the bottom one is coming from the 3 electrons that are moving around. And we're going to explain this now in greater detail on the next few slides. So because of this kind of discovery about benzene, we know that the electrons are equally shared because of this blurring above and below the plane. So the electrons are equally shared between the carbon atoms and exist as 2 clouds, one above and one below the plane of the carbon ring. Since these 6 electrons are not confined to specific carbons, they're said to be delocalized because they're obviously moving around if we have clouds forming, so they must be delocalized. And this is usually represented in structural formulas as a hexagon with a circle in the center to represent the shared nature of the electrons. So in benzene then, the delocalization of the electrons explains why the alternating double and single bonds do not occur. And this delocalization actually gives extra stability. And this is further proved when benzene is placed in bromine, no decolorization occurs. So that means there is no double bond present. Instead, we have our delocalized electrons forming our electron clouds above and below the plane, which is represented in benzene simply by a ring like I've just drawn. Now, benzene is nonpolar, and this is due to the small electronegativity difference between the carbon and the hydrogen. Benzene is classified as an aromatic compound and it is carcinogenic. However, many aromatic compounds that are less carcinogenic form the basis of many pharmaceutical compounds. Not all aromatic compounds are carcinogenic, and an example of this is aspirin, which can be found in paracetamol. Aromatic compounds are also the basis for certain acid-base indicators, such as phenolphthalein and methyl orange. Benzene is found in a lot of consumer products as well, so it's found in narcotics, so for example heroin and cocaine, and this here is the structure of heroin, so as you can see it's actually very complicated. Benzene can also be found in disinfectants, so for example TCP, which has this structure here, and it can also be found in food flavourings such as vanilla. So some examples of organic natural products are menthol, which is this structure here, and geranol, which is found in rose oil and is this structure here. Now you'll never be asked to draw these, but you may be asked to name. So that's it for this video. Have a read over the learning intention to make sure you understand everything we've gone through.